Isometric axis is nothing but three mutually perpendicular axes. If you take this as x, y, and this will be the z. So x, y, z will be mutually perpendicular, and you have to make these three axes equally inclined to your plane, something like this. So when it is inclined, even though they are at 90 degrees, they look like inclined at 120 degrees to each other. So these are called as isometric axes. So if you take this as x and y, and this will be the z. So but they will be mutually perpendicular to each other, but when they incline to a plane equally, then they look like at 120 degrees. So this will be at 120 degrees. If you draw a horizontal line passing through this point where three mutually perpendicular axes, what they call it as isometric axes, meet, then these two, they look like inclined at 30 degrees to a horizontal line. So these are called as horizontal isometric axis, like x and y. If they are horizontal, this is the vertical axis. So this is the horizontal surface and this is the vertical surface. Something like if you take a box, this, and if these are horizontal surfaces, horizontal axis, and this is vertical, then you have to keep these three mutually perpendicular axes to this plane inclined at equally inclined. So this line will incline with say same inclination, and even this is inclined with the same inclination with this plane. Then the view what you look at is called as isometric view. If it is drawn with the isometric scale, it is called as isometric projection. And these two lines is nothing but they incline at 120 degrees. When you want to draw any, say a rectangle or a square, a plane figure, if it is a horizontal, a square is nothing but having equal sides inclined at 90 degrees to each other. In that case, if I take this as a point corner where the three mutually perpendicular axes coincides, so then if I keep these two axes in such a position that these two edges make equal inclination with this plane, if I incline in that way, something like this, this is the surface, if say this is the square, then even though they are at 90 degrees, they look like inclined at 120 degrees when I project on them. So then if I want to go for that, so this is my view, what I look at, where the three mutually perpendicular axes make equal inclination. If this is my right and if this is the left, then this will be the right edge and this will be the left edge. So then what I'll do is I'll go for drawing this, because these two lengths of these edges which are at 90 degrees, they incline and they look like at 20 degrees on this. The projection of this, because they incline with some angle, that will be apparent. This length will be apparent, and even this angle, which even though it is at 90 degrees, look like inclined at 120 degrees. So for that we have to go for finding the isometric lengths, which are apparent lengths. So for that you have to construct a scale called as isometric scale. To construct the isometric scale, I'm not going to detail, okay? I'll tell you how to construct the scale, and that scale will be used whenever you draw the isometric projection. So this is a horizontal line. Draw a line inclined at 30 degrees to this line and a line at 45 degrees. So when you incline this line, if this is say the edge, which is when it's horizontal, when you incline that edge with that inclination, it looks like 30 degrees. But the true length will be in this position. Say if I turn in this way, if I turn this to give the inclination of this, even though it is inclined at say 45 degrees, when this is the position, when I turn in this way, okay, to horizontal, it will be at 45 degrees. When I turn this to give an inclination of 30 degrees, equal inclination, then it looks like at 30 degrees. That is nothing but your isometric scale, and this is actual scale. And to get the isometric length, what we'll do is you can measure the true length of the edge and just project that on this line. As to say, it should be perpendicular to this horizontal line. Then if this is OA, isometric of OA will be this OA dash. If OP is the true length, just project on this 30 degree line. Then this length OB dash, so OB the true length and OB dash will be the isometric length. So that will be always shorter than this actual length by 0.816. That is the scale. Whenever you construct or draw the isometric projection, always the all actual length should be converted into isometric lengths, and that length should be used to draw the isometric projection. If you draw the isometric views where the two mutually perpendicular axes inclined at 120 degrees and they look like inclined at 30 degrees, so then any line what you draw should be reduced by this length. So this, you have to take the length, isometric length, to construct that isometric view. In that case, any length what you draw in isometric projection should be converted to isometric length. The true length should be converted into isometric length, and that length should be used to draw the isometric projection. I'll go for drawing this square when it is horizontal position. In that case, what we'll do is we'll go for drawing a line, a horizontal line, then draw. So this is the isometric, the intersection of isometric axis. Then this is the point. So then these two edges will be inclined at 30 degrees to the horizontal. Same thing I'll draw now here. 30 and 30. Then you have to take the true length of this and convert that length on this isometric, transfer that on this true length edge, and you convert that into isometric length. So now you have to take this length to draw that square. If this is say 30 mm, then if you take the 30 length and if you transfer here on the true length and if you project, so this projected length, what you call it as isometric length, will be now be 0.816 of that. That reduced length should be taken to draw this square here. Then if you transfer that, so because these lengths will be same, and transfer the same length, then parallel to this 30 if I draw a line, and again parallel to this line if I draw a line, then this will be the isometric view of that square when it is in horizontal position. The same way, if it is say drawn, if it is a vertical surface, something like this, then vertical surface, so this is the horizontal line and this is the vertical line, then it will be inclined something like this. So it will be in this position. So then the horizontal line, so this is the vertical. Say if this is horizontal and this is vertical, I have to incline these two mutually perpendicular axes to incline with this, say the plane, incline at 30 and some equal inclinations. Okay, so then this vertical edge remains vertical, but it will be bent in this way, so that length will be get reduced to isometric, whereas this will be now looks like at 30 degrees. So in that case, the same, if it is drawn, say if it is a vertical surface, then we'll be draw this horizontal line. These two will now, horizontal lines will incline at 30 degrees, but the vertical lines remains vertical. So then this horizontal axis will incline at 30 degrees, whereas vertical remains vertical. So and again we're going to take the same length, so that converted length from the isometric, what we have here, so will be taken and it will be transferred here. So and again in the same way we're going to transfer this. So then if we draw two lines parallel to this isometric axis, then you're going to get this isometric view of the square in vertical position. So then this will be the view. So we're going to make this dark. So this is when it is horizontal and this is when it is vertical. So where these two horizontal, when I say horizontal, this is the horizontal and this will be the vertical. So horizontal, when I horizontal incline the horizontal, this is the position. So this isometric axis where they intersect and the axis when they are moving from this point, okay, the horizon, and all should be equally inclined. In that case you can see this vertical line is remaining vertical but it inclines. So in this position it is perpendicular, now it is inclined with the same inclination what these two are making. Then this is the surface what I have drawn here, and this is the surface it look like at 30 degrees, the horizontal surface, and this is the vertical surface. Say if we have a triangle or any other point, say if you want to mark a point on this some area. So this point, when you want to transfer that on this line, you cannot measure this length and transfer from this corner. If this is say A, B, C, D, and if this is A, B, C, D, then from B you cannot take this length and transfer that into isometric, and you cannot transfer. Instead you have to make this point to lie parallel to this isometric axis. So then you have to take this, so this is right side, so on BC you're going to have this point. I'll take that point, I'll just draw that line taking the isometric length of this. I'll take the isometric length of this actual length, I'll convert using this scale. I'll come back here to mark that isometric length from this B to say, so 1, 1, right, B to 1. So then parallel to this, if I draw a line, I'll draw the line this 1, 1 parallel to that. Same way if I want to draw 2, 2, then I have to take this B2, transfer that B2 on this line, get the projected length, so isometric length, that length you have to now transfer on this line from B to 2, then draw that line to get this point. So that way any point which is not lying on the isometric should be transferred by taking two axes which are parallel to isometric axis. In that way any curve what you draw, any distance what you measure, you cannot measure directly on this line. Instead you have to locate the point by taking the isometric axis are parallel to isometric axis. I'll go for a simple solid like prism and see how that can be drawn. So for drawing isometric projection of any simple solid like prism, so I need to construct the top and front view, orthographic views what you call. So from the orthographic views we can get actually the pictorial views, what we call it as isometric. So say if this is the pentagonal pyramid having one of its rectangular surface, so that is A, B, C, D, E, A1, B1, B, C, C1, D1, E1. So if I say go for drawing this height of the solid, say this is having a side equal to some 30 mm and the height of this, the axis, say this is the axis, and this is A, B, C, D, with dashes, and this is A1, B1 dash, C1 dash, D1 dash, and E1 dash, and this is a O1 dash, and this is O1. And if you want to draw this in isometric projection, then what I'll do is I'm going to inscribe this, because you're going to have a points. All these points should lie on what we call the isometric axis. So I'll inscribe this pentagon in a rectangle. Now we can take these two axes as isometric axes which are perpendicular to each other. If I look at this point, if I make these two edges equally inclined, something like this, then only two surfaces you can see, but if I take this edge, I can see actually three surfaces. So you understand when you go for this, always you have to select the corner where you have only the points on the edges of intersecting that corner, which are intersected by two edges, should have only one point, not 2 points like this. So then you can see the maximum surfaces. So always in isometric projection, because it's a single view, so you should see the maximum details in the same view. So for that, always you select this corner or this corner. In that case, if I take this corner, say, so I'll go for drawing a line, horizontal line, then I'll draw this BC, say if this is the point, inclined at 30 degrees, if this is at 30 degrees. Then this length will not be equal to this length. Always this length will be bigger than this length. In that case, so if I want to go for drawing this pentagon from this corner, looking at this corner, otherwise I'll say that this is the origin of three mutually perpendicular axis, isometric axis. Then this is my axis, what I'm looking for. Then this is my right and this is my left. So this is right and this is left. So in that case, you're going to have a point C and C1 on the left side, whereas on D and D1 right side. I told you the C1, this length. If I take this as say 1, 2, 3, 4 is the rectangle. Then if I'm looking at the point 3, then 2, 3 will be on my right side, because I'm looking from here, right side, and this will be on the left side. So 3 to 2 will be on the right side. So in that case, I cannot take that 3, 2 and draw directly here. Instead, I have to go for converting that length into isometric. So then I'll take this, say 2, 3, which is on the right side. This is my right side and this is my left side. So right side 2 to 3. So I have to get this 2. Then I will take this length, I will convert that into isometric, project that, get that isometric length of that. Okay. So then take that length and you mark it here to get the 2. Whereas this 4, 3 to 4 will be less than this 2, 3. Then I'll take this 2 to 3 and I'll project that. Now 4, 3. Sorry, 4, 3. So this is my 4, 3 and this is 2, 3. So I'll take this 4, 3 length. That is the length of this rectangle edge 4, 3, 4. Edge of the 3, 4 is the edge of the rectangle, which is smaller. and this is 2 3 is bigger, so in that case, so 3 4 I will just convert that isometric length. If I transfer here, then this becomes 4, then this 3 4 will be proportionately smaller than this, the same way what you see here. Then parallel to this edges you complete, you draw a parallel line and complete this rectangle parallel to this. From this point to fixing your mini drafter, you can go for drawing that line. This is your 1 2 3 4 rectangle. This 1 2 3 4. So 1 is here, so I'm looking at 3. So this. Then on 2 3 you will have D. So then take 3 to D or 2 to D. 2 to D or 3 to D, the same. So convert that into isometric. Any length what you transfer from this view should be converted into isometric length, and that length should be used here. So in that case we'll take the 3D. So isometric of 3D, I'll just project it. I'll get that of that 3D project and get this isometric length. So that length I'll transfer here to get the point D. The same way this 3C, I'll just convert from the isometric. So isometric of 3C. So isometric of 3C is here. So project that, get that length, and U transfer it. So this will be your C. So because C and E will be at the same length, I can get that point also E. Then again this 1B to 4 and A to 4 remains same. In that case, I'll take the isometric length of this 4 to B and 1 to A, same. So then taking that isometric length from the isometric scale, I can go for marking that points A and B. And this will be A, this will be B now. This is C, this is D, and this will be E. In that case, if I join all these edges, I'll want to get my pentagon in isometric view. This is my pentagon in isometric view. So if you want to draw this, say the pentagon, there are two methods. One, you can draw the box. So height of this will be given, say if this is 50 mm, height of the solid is 50 mm. Then that 50 I can take here and convert that into isometric length. So using that length, okay, so I can go for projecting all these points at the corner to move up by isometric of 50, isometric of 50, from here again isometric of 50 and isometric of 50. So on this I'll take that isometric of this 50, converting that to get this isometric of length. I will transfer and I'll mark all the points, 1 isometric of 50, 50, isometric of 50. Then I'll go to get a similar rectangle which is available here. So that is 1 2 3 4, a similar triangle. And that I can directly project to get these points. If this is A1, B1, C1, D1 and E1 of the base, then this will be my, if I project this point again, this will be my A1, A, the top surface, okay, this is B. Similarly, I can project this point to get this point C. Project this point vertically, while drawing a vertical line, okay. So this is my D, and if I project this, this will be my E. So then if I join all these points in the order A, B, C, then D, E and E. So, and if I join all the edges, I'm going to get this vertical, the isometric projection of rectangle. So for that, what we'll do is, first always you should start from the top, let it be thin when you draw, okay. Just go for making these edges from the top, which are visible edges, using HB pencil. Just complete this with a thick continuous line. So then you go for the outermost, this is outermost, and this is outermost. So this is the front edges which are visible. Just go for front. These are the front edges. This C1 and A1. Just make them using HB. So need not draw these edges. These edges need not draw. Let it be very thin as previously drawn, only these edges. So A, B, B, C, C, D, D, then B, B1, B1, C, C1, D1, D1, E1, 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 so outermost edge, and D, D1 and C, C1. And this is the view in isometric projection. So where this length of the axis, if you take the axis, same if you want to locate the axis, then again you have to go for drawing a line parallel to these two mutually perpendicular axes what I have taken. So D is going to have a axis parallel to this, and check out from 4 to this length, convert that into isometric, then you draw a line, then if you draw, this will be the axis of this line. It starts from here to here. Again, if I project, I'm going to get that axis, something like this. So this will be the axis line, so need not show, but whenever you want to draw for combination of solids, then you have to locate the axis so that the axis of one solid should coincide with the other. So there will be a combination of solids where they say to draw the isometric projection of combination of solids having their axis collinear, coaxial. In that case you have to locate the axis, then you have to place that the axis of the other solid what you draw here to coincide with this axis line. So in that case you require this line, let it be very very thin, you need not draw that. Just you can show like a axis line, a chain line. So I'll go for drawing a pyramid. We'll see how the pyramid can be drawn using this. This is a pyramid and isometric projection. So same procedure, I'll go for drawing an hexagonal pyramid. You know how to construct hexagonal pyramid using circle method. You construct them, and if this is A, B, C, D, E, F, then this is the vertex. Because it's a pyramid, all the edges are visible. The inclined edges, what you call, are visible, and these are all the base edges. So corresponding view in the front will be a base. Then move, if this is O1, then we're going to have the apex will be the height of the solid. This is say 50 mm. Then from that apex you have to go for joining all this A, B, C, D, E, F. So all dashes because they are front views. Complete that. So then whenever you want to draw this isometric projection of a pyramid, you have to again inscribe this in a rectangle. Again in this rectangle. So I'd say this is 1, 2, 3, 4. Because the symmetry in all the position, you can take any corner as isometric axis, the origin of the isometric axis, and this is 1, 2, 3, 4. So again you can see that the 2, 3 is bigger than this 4, 3. In that case, if I am say looking at again 3, then drawing this isometric projection will be something like this. You go for drawing a line, horizontal line, draw a line inclined at 30 degrees from a point, okay, 2 lines to that horizontal line from this point. I take this as a point 3, so where I'll take the isometric axis meeting at this particular point. Then 2, 3 is on my right and 3, 4 is on my left. So I'll go for getting the 2. So take this length, convert on this. So take this length 2, 3. So transfer this, then project that length to get the isometric length. So all the length should be converted. So that isometric length of this 2, 3 is less than the 2, 3. I'll just get that point 2. Then 3, 4, which is actual length, I should convert again using this isometric scale, any length. Say if this is 2 3, then project that line, get that 2 3, not 2 3, sorry, 3 4. So this 3 4, 2 3 is already well done, 3 4. Then get that 3 4, isometric of 3 4. If I draw parallel to these edges, parallel to this again, then I'm going to get a rectangle in horizontal position. So then have D and E on this line. Okay, so then 3 to D will be equal to 2 to E and also equal to 1 to A and 4 to B. Then I can take this 1 to 2E, 3D, B4 and A1 all are same. I can transfer and project, get the apparent length, or what you call the isometric length. If I transfer them on this line, then I'm going to get this as D and this as E. In the same way, I'm going to get this B and this as A. Then 3C, this 3C I can get is the midpoint of this, because this 3 4 what I am getting is the isometric length of this 3 4. Then again I have to take this 3C, then transfer here, get that isometric length from here to get that point. So then again on this 3 4, the C will be actually the midpoint of this shortened length, because the 3C what I take is again apparent length of 3C, which is half of this 4C. Then again that will be the midpoint. Same I can get this point if I join them. Then I'm going to get the base of this pyramid and locate the center. So because it's the center line, because the axis lies in this line. Again one more horizontal line to locate this O. I have to draw. So that is from 3 to this length. I'll transfer that into isometric length. The same 3 to that isometric of that length I will get, and I will get that axis. This is my axis. Then draw this vertical line. So the vertical line will be now parallel to the vertical, what you call isometric axis, Z axis, isometric Z axis. Then that 50 what I have should convert into, that should be converted into isometric length of 50. So then this will be iso of 50. So that will be always less than 50 by converting using this scale. So I'll go for that. I'll take that 50 and get that isometric length. That line should be transferred to get that vertex. Then you go for the outermost edge. This, you check out whether this is outermost or this is outermost. So always this will be outermost, I think. Okay, so because I'm not properly written for the scale. So then this will be the outermost, say. So then this will be the outermost, and this is outermost, this is outermost, this is outermost, and this will be the outermost. Then these edges you can see, in the sense you can join them using a thick line. So if you can see this, okay, otherwise if this is covering and if this comes inside, no problem, you can just go for drawing that line and that will be within that. So you can see actually 3 surfaces, then this will be the line. See, this is your line and this will come inside. And then we go for joining all these edges with the continuous line using HP. No need to draw these invisible edges using HP. This is the isometric projection of pyramid. So same procedure for any of the pyramid. You have to construct the base, then locate the center. From the center, move up vertically, perpendicular to this XY line, to a height equal to isometric length of that height. That will be less than that actual height. Okay, locate that point. From that point, you have to go for joining a line to the outermost. If this is outermost, this point, okay. If this is outermost, you have to draw that line. Then you complete all the boundary edges which are in the front. making this area. Then these front edges which are near to the observer can see, then the all visible edges should be marked with a thick line. The same procedure for all these pyramids, whether it is square, pentagon, or triangular, anything. If it is a square pyramid, it will be something looking like this. If it's a square pyramid, something like this, the square is drawn with isometric length. You get that axis line, move up by isometric of axis length. Then when you get here, you can just close. This will be the outermost edges, and this is the outermost boundary, and this is your visible edge. In that case, you will not see this edge. Instead, you are going to have only this 3 plus 4 plus 5. No, this edge will not be visible. So that will be thin line. It will be something like this. If you just close this line, okay, something like this. Otherwise, I'll just draw separately here. So a cube, what do you call square? It will be actually exactly something like this. Locate the center, move up by isometric height of the solid, then outermost edge. This is my front edge, just the boundary, then visible edge. So make only these edges which are visible using HP, thick line, not these two. So only these front edges, then all outermost boundaries and visible edges will be made dark.